Hi, welcome back to Intermediate Algebra. Today we're going to look at systems of equations with three variables in them. So these aren't necessarily harder than the ones with two variables. They are, however, a much bigger mess. And so we're going to have to be really careful. You're going to have to definitely be very neat and tidy with your work here, because if you're not, you're going to lose track of stuff and it will go not where you want it to go. So please be careful. Please be neat. And hopefully this works out well. So for starters, here on the board behind me, I have some steps that you should go through. I highly recommend that you write these down. That way you'll have them to look at when we get to the next board and I start doing some examples. So steps, number one, you're going to start with three equations with three different variables in them. And so what you're going to do first is you're going to trim it down from 3 to 2. Okay, so just like when we had the elimination method with two variables and we got rid of one of those variables, we're going to get rid of one here. The difference is, since we're starting with 3, we're going to have to eliminate one of those, but we have to do it twice. So we're going to pick two different pairs of those equations to get rid of one of the variables, and we'll see that on the next board when we get an example. So we go from 3 variables down to 2 variables, from 3 equations down to 2 equations. That's going to kind of be the theme here. 3 to 2, and then 2 to 1, and then, well, you'll see. All right, so anyway, get rid of that first variable. Once you do that, you're going to have 2 new equations. And the nice thing is they should only have 2 variables. So we've taken it from 3 down to 2, and now we do that exact same thing again. We're going to eliminate one of those variables to go down from 2 to 1. So you use those 2 equations to eliminate. Now you just have an equation with 1 variable, and you solve it. Okay, should be pretty straightforward once you get to it. That step should be pretty straightforward if you get there. Once you solve it, you go backwards. So remember, we went from 3 variables to 2 variables down to 1 and solved. Now that we've got that first one, we go back to an equation that has 2 variables, and we plug it in, and we solve for that second variable. Once we have those 2, we plug it in again, but now we plug it in back in one of the equations that had 3 variables, and we solve that. So hold on for just a second. I'm going to erase my board and get an example up there, and we'll talk our way through that. So here we go. All right, so here we go. Our first example. And these are a disaster. They're just really, really messy, and they're very easy to make mistakes on. So please be very, very careful. I really can't even possibly stress that enough. So take your time going through this video, because unfortunately I've got a little teeny board and that makes it really tricky to make it all look really pretty. So I'm going to do my best, kind of show you where I'm going. But take your time going through this. Pause it, figure out exactly what I'm working with, and you'll be fine. All right, so here I have my system of equations. I have x plus y plus z is equal to 6, negative x plus 2y plus z is equal to 6, and 2x plus 3y minus 4z is equal to negative 4. Now, I can get rid of any of those 3 variables that I want. Okay, honestly, x is a great choice. That's the one I'm going to end up working with. But because we have just plain x, y, and z in that first equation, really any of the 3 are going to work out pretty good. But definitely take a minute when you start one of these and take a look and see if there's one variable that's going to be easiest to get rid of first. And if there is, go for that one. If there isn't, then, well, have fun. That's when it gets even messier. But so anyway, I'm choosing to get rid of x here as my first variable to get rid of. And now you'll notice that I've labeled here 2 pairs. I have the top two equations that I've labeled with a 1, and the bottom 2 equations that I labeled with a 2. So I'm going to kind of take you through the steps of putting these things together here. And so try and follow along. I know my board is not great here. So anyway, let's look at those first 2 pairs. The first 2 pairs, I brought them over here, and we can see them. I have x plus y plus z equals 6, and negative x plus 2y plus z is equal to 6. Because the x's are already opposites, I don't have to do anything to get rid of the x's. I just have to add these 2 equations together. So I do that. I add them. X and negative x is 0. Those go away. Y and 2y is 3y. Z and z is 2z, and 6 and 6 make 12. Again, be super careful when you're going through here. Any one teeny tiny little mistake is going to mess the whole thing up. So please be really careful. And if you're taking one of my tests and this is on there, make sure you show me all of your work really well, because I have a lot of experience working with this stuff and trying to find little tiny things that go wrong. And then, if it's something tiny, you're going to get a lot of partial credit. Anyway, so I have this first equation now that I wanted. It has just y and z. The x's are gone, but it still has two letters. I can't solve that as it is right now, so that's why I'm also then working with this second pair. So I brought them over. Negative x, 2y and z equals 6. 2x and 3y minus 4z is equal to negative 4. This time, so I need to get rid of the same letter. I don't want to do x in one and then y in a different one. That wouldn't be very good. So I need to get rid of the x's again. This time they don't match, right? I have a negative x and a positive 2x. So I'm multiplying that first equation by 2, which gets me negative 2x plus 4y plus 2z is equal to 12. And then I just bring that second equation straight over. When I add those, now the x's go away. 4 and 3 makes 7y. 2 and negative 4 is a negative 2z, and 12 and negative 4 makes 8. Okay, again, be really careful. And like I said, if we need to, pause this, figure out what I'm pulling from, what I'm working with here. So I took those first two equations to get rid of x, then I took the second two equations and had to do a little bit more work to make that go away. All right, so now I have these two equations that both have just y and z. So you'll notice I brought those together here at number 3. Okay, so if you can even read that. Number 3 on my board. So now I have y and z, and conveniently the z's are already opposites. So I don't have to do anything like I did here where I had to multiply to get opposites. I already have opposites, so I just add them together. 3 and 7 makes 10y. The z's go away. 12 and 8 make 20. Divide both sides by 10, and we finally get that y is equal to 2. There we go. That's great. We have our first variable. Okay? And so now, let's run through what we just did, because we're going to take what we did and we're going to do it in reverse here in just a second. So we took 3 variables and we put them together in pairs to cut down to 2 equations with 2 variables. We took those two, we put them together to get an equation that only had 1 variable and solved it. Now that we have that answer, we need to go backwards to find the other 2 letters. So we still need x and z. I'm not going to come back here yet. Okay, these have 3 variables in them still. If I plug in that 2, I still can't figure out what x and z are going to be. So instead, I take it back to one of these 2 equations that I found that had just y and z. You'll see I put an arrow here. I'm going to plug that 2 in for y in this equation. There's nothing special about this equation. I could have used that one just as well. So I plug it in. 7 times 2 is 14. I kind of went through this algebra pretty quick because I was running out of room, but I subtracted the 14 from both sides, which gave me negative 6. Then I divided both sides by negative 2, and now I have z. Z is 3. So now I know 2 of those letters. I have y, I have z. The only thing missing, x. And for that, we come back to where we have all 3 variables, x, y, and z. Again, you can use any of those 3 equations at this point. I'm going to choose to use the first one. Why? I kind of liked it. The letters were all pretty simple, no coefficients. So I plug in 2 and 3, and I did that here. 2 and 3 is 5. Subtract the 5, and you get 1. So x is 1, y is 2, and z is 3. And I write my answer as an ordered triple. And those are so very much fun. So there you go. I'll do one more example for you, and then you're going to be on your own having loads of fun with the book. One thing that I probably won't get to in this video, because YouTube doesn't like to give me loads and loads of time, and quite frankly, you don't want to watch an hour-long video. If you have fractions, okay, what happens if you have fractions in here? Remember, we learned a trick back when we did 2 variables to get rid of fractions. You can always multiply an equation by its common denominator, and that would clear out your fractions. So, for instance, if this was 2/3 instead of 2, I could just multiply everything in that equation by 3. All that fraction would disappear, and then we wouldn't have to worry about it. So, like I said, I'm not going to get to fractions. So I'm going to do one more example, though. Okay, here's the second example I wanted to show you. I put this one on the board because a lot of times it kind of confuses people, and we'll talk about why here in just a second. So I want to do this one it actually turns out that these are a little bit easier than the last example we looked at, and we'll see why. But here's why it kind of throws people off. If you look at my system of equations that I have here, I have x minus y is equal to -3, x plus z is equal to 2, and y minus z is equal to 7. Probably the first thing that you notice is that even though we have 3 equations, each equation only has 2 variables. It's a little bit weird. It doesn't seem quite right. But let's see what happens if we start working our way through this. We still want to do the same thing. We want to end up with an equation that only has 1 variable, so we can solve that and then backtrack. So here we go. I'm going to start by getting rid of z. I'm like, right, we got to get rid of something. So if I take these 2 equations, which I brought over here, the z's are opposites already, which is why I chose that one. And so when I add, the z's go away. 2 and 7 make 9, the z's go away. But over here, we have x plus y. Those are not like terms, so we can't just smash them together. So you'll notice I wrote down x plus y is equal to 9. Right? The x and y are still there. Z's went away, but we have x plus y is equal to 9. You're like, gee, great, now I have that. Why is that so special? Well, it's special because that's an equation with 2 variables, and it matches the variables in that third equation. So anytime you have this kind of setup where you have 3 equations and each of them only has 2 variables, if you pair 2 of them up to get rid of a variable, you'll be left with something that matches the variables in that third equation. That's why this is actually easier. Again, the y's are opposites, so I add x and x make 2x, 9 and -3 is 6. I divide by 2, and now I know x. X is 3. That wasn't so bad. And here's where it gets even better. Because everything only has 2 variables, I can just plug in that 3. So I chose this equation to plug the 3 into to find z. So I had x plus z is equal to 2. I plug in 3. 3 plus z is equal to 2. When I subtract 3 from both sides, I get z is -1. Now, over there, I'm using the first equation, x minus y is equal to -3. And again, I plug in the 3 for x. Subtract 3 from both sides gives me -6. Be careful here. Don't lose that negative sign that's with the y. That would be a very easy thing to lose, and it would mess up your answer if you lost it. So we still have to divide both sides by -1. We get an answer of 6. And putting it all together, we have 3, 6, and -1 for our answer. Pretty fun. So anyway, good luck with these. Again, remember, please be neat. Okay? I know some of you, that's a really hard thing. I've been teaching math a long time, and I get people whose handwriting is amazing and their organizational skills is awesome. And I get people who are the exact opposite of that. And if that's you, this is going to be something that is going to be a bit of a struggle for you. So work on that organization, because it's really going to help your cause to try and get these to work the way you want them to. So good luck.